Hello students, welcome back to my YouTube channel. Today I will discuss a very important question taken from circular motion and based on the concept of pseudo force. A vertical rod is rotating about its axis with a uniform angular speed omega. Full stop. A simple pendulum of length L is attached to its upper end. What is its inclination with the rod? Try to understand what is the question with a proper diagram. Now, according to question, this is a rod, is a vertical rod. This rod fixed with an axis, correct? Now, this axis rotated with angular speed omega, with constant angular speed. Upper end of the rod is this. A thread of length L is hang with mass m, and this look like a simple pendulum. This is a simple pendulum, length L. Now, this angle is theta. Rod rotated with angular speed. So, on the mass m, a pseudo force act away from the center of the circle, like this. This is the circle. A mass of the bob rotated in this circle, like this. So angle formed by the rod and the A length is theta. Okay, attached to its upper end. What is the inclination with the rod? Inclination means that something angle. Okay, this is the L. Consider this is the x. And this is the pseudo force m omega square x. This is the pseudo force in the case of circular motion. As we know, F equal to mv square divided by r. This is the centripetal force. Now, m omega square r square divided by r, that is m omega square r. This is the centrifugal force. In centripetal force, we use v, and in case of centrifugal force, we consider omega, because a frame rotated with omega. So this is very simple and this is a very basic concept. Now, m omega square x away from the center, this is the mg. This is the weight force. Now, string becomes stretched, so tension in the string is T. Now, consider the axis on the bob. This is x-axis and this is the y-axis, correct? This is theta, so this is also theta. So, component of T along y-axis is T cos theta. Any doubt? And component of T along x-axis, T sin theta, correct? Correct. Now, this M comes in equilibrium with respect to frame. So, this is the T, it's the mg. Again, this is the T cos theta, and this is T sin theta. And this is the m omega square x, correct? Bob, this is called bob. A small m, mass of a small m is called bob in case of simple pendulum. Bob is at rest with respect to frame. Okay. Now, if y equal to 0, net force and y equal to 0, so we can write T cos theta upward, T cos theta, and downward with negative sign mg. This is the mg equal to 0. So we can write T cos theta is equal to mg. Again, if x equal to 0, so m omega square along positive direction, m omega square x minus T sin theta with negative x-axis. This is the T sin theta equal to 0. So, T sin theta equal to m omega square x, correct? Now, from geometry, this is the 90 degree, okay? This is the theta. So, this is the hypotenuse and this is the perpendicular. So, now sin theta, we can write Sin theta is equal to perpendicular in this triangle. This is the perpendicular. Perpendicular is the x, and this is the hypotenuse. This is the L. So perpendicular x divided by L. So x equal to L sin theta. Correct? Now x equal to here t sin theta equal to m omega square into L sin theta. This is and this is cancel. So t m omega square L. Correct? Now putting the value of t in equation first. This is the first and this is the second. Correct? You will get value of theta. Okay? From first and second. T means that m omega square L into cos theta equal to mg. Correct? mg. M and m cancel out. So cos theta equal to g divided by omega square into L. Now theta equal to cos inverse. This is the basic mathematics. We have studied in inverse trigonometric function. This is g omega square L. Correct? Answer. Theta equal to cos inverse. G is the acceleration due to gravity. This is the constant values. Omega is given in the question. Now omega is given in the question. And L is the length of simple pendulum given there. Okay, this is the theta and theta from the vertical. This is angle from the vertical. Suppose that angle from here, this is the horizontal. From vertical. Very important and very conceptual question. Okay, please subscribe to my YouTube channel, share the video and like it. Thank you.